Welcome to qnawire.
Okay, so we have some data on number of popular coffeehouse chains, and you can see right away that the number is steadily growing. But at 2008, whatever led up to that, we lost a lot of coffeehouse changes. And so anyway, after that, it kept growing. So that's kind of interesting. Anyway, so we're going to study the data. First thing we're going to do is look at average rate of growth. And we're going to look at that for, whoops, let's make sure we can read that, average rate of growth. And we're going to make sure that we know what times. Okay, so our first time of interest is 2006 to 2008. To find the average rate of growth, it's just basically rise over run. We're going to look at the number in 2008 minus the number in 2006, that's our rise over our run, and our run is, let's make a better line, there we go. And our run is just then the difference in the years. Okay, so when we plug all that in, let's see, 2008, it's 10,680 minus 12,440 over just two years. So let's make that a little nicer, over just 2 years. So when we plug that in our calculator, we get minus 880 chains per year. So that makes sense. We kind of noticed that leading up to 2008, we were losing chains. So that's not very good anyway, but there was a loss of that per year. So let's take a look now at looking at between 2008 going to 2010. So therefore, we'll take the number at 2010 minus the number at 2008. And once again, we'll subtract our years at the bottom. So rise over run. So this time we get, let's see, 2010, we get 16,858 minus 10,680. This will be a lot better growth over 2 years. So this does give us way better, a positive 189 chains per year. So much better growth leading up to 2010. Okay, so now what we're going to do is find an approximation for the actual instantaneous growth at 2010 by basically averaging the left and right side. We already have kind of the left side here. So let's go ahead and find the average rate of growth from 2010 to 2012. Okay, so 2010 to 2012. So that will give us, we'll go ahead, we kind of know what we're doing here, rise over run. And so we will plug those values in. Let's see, on the 2012, we have 18,066 minus 16,858 over 2 years. So those last 2 years, we still had growth, but it was 604 chains per year. Okay, so the idea is that if we want to look at just 2012 and get the instantaneous rate of growth, so basically the instantaneous rate or the derivative at 2010, we can approximate it. One way is to average what we get on the left of 2010 and what we get on the right. So we're going to average this and this set. So we're going to average our 1089 plus our 604. We'll divide by 2 to get the average, and our average is 846.5 chains per year. So if we were to do our best guess at 2010, what was the rate right then, we would do average of the left and the right, and we get 846.5 chains per year. The last bit is to see how close you can get by graphing. Challenging to graph when you have only the 5 data points. So what happens when you try to graph is you have data points that are kind of like this, and not easy to get a graph. You could do a kind of a quartic type graph to get some kind of thing. To get a data point, you could do a parabola and just focus on, say, the 3 points here. So I played around with a couple different ways to get a slope, and none of them were very practical. So I would say if you were to draw this by hand, the best thing you could do would be to again, you have to choose. You have to choose, are you going to do a quadratic? Are you going to do a quartic? What kind of curve fit are you going to do, and what can you get out of it? So I would say this last part about a tangent line, you would just have to draw it yourself and get your best guess with a tangent line 2 scale, which is a bit beyond what we can do on this whiteboard. So anyway, hopefully that helped. Have a wonderful day.